Hello everybody, getting ready to do lesson 3.7 of Algebra 1. It will be part 1, part 2, and part 3 was available, as well as other course materials. 3.7, graphing linear functions. Here's your standard. It is part 1, and we have a 34-point skill sheet that you can acquire. But there's no notes to take here, so it's all skill check. Okay, teachers, your bell work here for your students. Here we have a table. Explain why P varies directly with L. So this is kind of like a written exercise. And then what is the longest chain you can buy? If you have 30 bucks, give your students 5 minutes on this. Okay, welcome back. We're going to have our solutions now to our bell work. And there's A, because each value of L times 1.25 gives you corresponding value of P. And then here's an explanation for B, represents change of cost per inch of length. So 30 times 1.25 would be, and L equals 24. So that would be 24 times 1.25 be 30. Okay, you've graphed linear equations and functions. You will use function notation so you can model an animal population. You've seen linear functions written in this form here, y equals mx plus b. By naming function f, you can write it using function notation. F of x equals mx plus b. And the symbol f of x is another name for y, and is read the value of f at x, or f of x, simply as f of x. It does not mean f times x. You can use letters other than f, such as name function. So example 1 here, standardized test practice was the value of f of x, 3x minus 15 when x equals negative 3. So we just plug in here. For x here, we plug in our negative 3, and we get negative 24. So that's how you use function notation for that. It would be A up here for that. Okay, our first guide practice here. Evaluate the function when x equals 7. Students, this is yours here to do. F of x when x equals negative 2, 0, and 3. So you got 3 here to do for this function here. Okay, when negative 7, so we just plug in 7 here, don't we? When x equals 7, we just plug it in for x, wherever x is. Negative 7 times 7 is negative 4. Okay, example, we're going to continue here. This is your lucky day, students. We're going to do yours too here. We're going to plug in negative 2, we're going to plug in 0, and plug in 3 here. So for negative 2, what do we get? We get positive 11. For 0, you get 5. And then for 3, negative 3 times 3, I don't know what this 15 is doing in here. It should be 5 here. So it'll be negative 3 times 3 would be negative 9 plus 5 would be negative 4 for that. So negative 9 plus 5 would be negative 4. Forget that. Okay. Example 2, find an x value for this function here. F of x equals 2x minus 10. Find a value of x so that f of x equals 6. So find a value of x so that f of x equals 6. So for this whole thing to equal 6, what does x have to be? So there's our original. We put our 6 over here. This has got to equal this. Okay, so we'll find out what x is. X would equal 8 for that. We bring this over here, and then divide both sides by 2, and we get x equals 8. So x equals 8 when f of x equals 6. Okay, so our next guided practice here, students, this is you here. Maybe I'll even do that one. Maybe really be your lucky day, but we're going to do this one first. 14 here. 6x plus 6x plus 9 when x equals 3. Okay. So when x equals 3, or rather when f of x equals 3, we put 3 where f of x is. 3 equals this. So we solve for 3, and then we move this over here, negative 9, negative 6, and then x equals negative 1. Okay, so that's part 1. Part 2 and part 3 are available here. Thank you very much.